Chapter 9, we are looking at one sample t-test. We are looking at one sample. We are given the information on a population. We are given the population mean, then population standard deviation. Those things were given to us. Then from that sample, we had a small sample. Then we had the information on each person in that sample. We calculated this x bar or m from that sample. And then we proceeded with standard error of the mean, standard deviation. First, we calculated S, standard deviation. Then we calculated SM, standard error of the mean. Then we calculated T of 10. Then we calculated Copens D. Here, things are changing. Instead of one sample, we have two samples. The key point here is these are independent samples. So they are unrelated samples. Two different samples. So sample 1 is N1, sample 2 is N2. So if you are calculating this mean from the sample 1, which is N1, you will call it as M1 or X1 bar. This one. Or you can write it as M1. From sample number 2, N2, we calculated the mean. So it is X2 bar. You can write it that way, or you can write it as M2. So M1, the mean of sample 1. M2, the mean of sample 2. And then we do these things step by step. First step, we write down the alternate hypothesis. Again, the main thing is we are dealing with, from these sample means, we are going to draw inference on population means. So when we are writing our hypothesis, we are not writing M or X bar. We are writing mu1 from the first sample and mu2 from the second sample. The idea is we have to prove that these sample means they are not equal. So we try to figure out if there is any significant difference between the sample means. From that, we draw a conclusive statement on the population. So we write down these alternate hypothesis, which is mu1 is not equal to mu2. Why? Because if you look at the question, it says it's a non-directional test. Non-directional, it is not telling you whether it's greater than or less than. So non-directional, right away, you will know we are talking about that's the non-directional. The next thing is we write down step 2, we write down the value of alpha. Alpha given to us is 0.05. Degrees of freedom is N1 plus N2. You add them up and then subtract 2. Why 2? Because we have two samples. Previously we were doing degrees of freedom equal N minus 1. So here we have N minus 1, N minus 1 twice. So we add those N1 plus N2 first, then subtract 2 to determine our degrees of freedom. And based on the value of alpha and the degrees of freedom, we look at this table 2, the T table, to find out our T critical. And then after that, it starts getting a little complicated compared to last time. So we have more calculations this time. It means we have to be more patient. So we calculate all these things and finally we calculate our T of 10. Once we calculate our T of 10, the main thing is if you look at the formula for T of 10, the one which is shown on your book, that T of 10 equal what? M1 minus M2 divided by S M1 minus M2. So based on those values, you can draw your conclusion. And then you use that formula for Cohen's-d to calculate the effect, the size effect. Then you look back and remember what was the highest one? 0.8, right? So anything more than 0.80 is large effect. Just remember that. And most of the time you will find out that it is more than 0.8. So that's how we calculate these things. Yes?
We'll still use this table.
Yeah.
Will it just always be for a two-tailed test?
It will tell you whether it's two-tailed or one-tailed. And your degrees of freedom is the first column.
Oh, right.
Yeah.
Okay.
So look at the degrees of freedom first, and then go to your right according to your one-tailed test or two-tailed.